Hello, everyone. Today we will learn about the specific requirements for installing fire water supply equipment. Through this lesson, I hope you will understand the composition and function of the fire water supply system and master the installation requirements for fire water tanks and elevated fire water tanks. The fire water supply system generally consists of fire water sources, including municipal water sources, fire water tanks, and natural water sources, water supply facilities, fire water supply pipes, control valves, etc. It is an infrastructure that supplies water to various water extinguishing systems, protective cooling systems, fire separation systems, and fire trucks or other mobile equipment during a fire. We will primarily focus on the installation requirements for fire water tanks and water supply facilities. Now, let's delve deeper into the composition and function of the fire water supply system. Firstly, the fire water tank. To ensure that the fire water supply system and the water extinguishing system have enough water volume during fire and to ensure reliable water use, the fire water tank should store all the fire water needed for the duration of the fire. Rational planning and arrangement of fire water tanks play a crucial role in ensuring building safety and reducing or mitigating losses. To ensure the reliability of fire water, the setup of fire water tanks should comply with the following regulations. 1. The effective volume of the fire water tank should meet the fire water demand during the designed continuous water supply time. When the fire water tank adopts a dual-source fire water supply and can continuously replenish water to meet the fire water demand during a fire, in cases where only an indoor fire hydrant system is installed, the effective volume should be greater than or equal to 50 cubic meters. Under other circumstances, it should be greater than or equal to 100 cubic meters. 2. For water tanks shared between firefighting and other uses, technical measures must be adopted to ensure that the water intended for firefighting is not used for other purposes. 3. The outlet pipes of the fire water tank should ensure that the water within the effective volume of the tank can be fully utilized. The minimum effective water level of the tank or the submerged depth of the fire pump's suction port should meet the requirements for safe operation of the fire pump at the lowest water level and achieve the designed output. 4. The water level of the fire water tank should be able to be displayed locally in the fire control room, and the tank should be equipped with high and low water level alarm devices. 5. Fire water tanks should be equipped with overflow pipes and drainage facilities, and indirect drainage should be adopted. 6. When the total effective storage volume of a fire water tank exceeds 500 cubic meters, it is advisable to have two compartments that can be used independently. When it exceeds 1,000 cubic meters, there should be two separate tanks that can operate independently. Each compartment, or tank, should have its own outlet pipe, and a communication pipe that meets the minimum effective water level should be installed, and its diameter should meet the design flow requirement for fire water supply. When a building adopts a high-pressure fire water supply system, if the total effective volume of the elevated fire water tank installed in the building exceeds 200 cubic meters, it is advisable to have two compartments with equal effective storage volumes that can be used independently. When the building height exceeds 100 meters, two separate tanks should be installed. Each compartment or tank should have a separate outlet pipe supplying water to the fire water supply system. Similar to the fire water pool is the elevated fire water tank. An elevated fire water tank stabilizes the pressure for the fire water supply system and the water extinguishing system when in a quasi-operational state, and provides an initial volume of water for firefighting during a fire outbreak. It is an essential facility for ensuring that the water extinguishing system can effectively tackle initial fires in buildings. For elevated fire water tanks, several technical requirements must be met. 1. The effective volume and pressure of the high-level fire water tank for indoor temporary high-pressure fire water supply systems should ensure the necessary amount of water for initial firefighting. 2. Manholes and valves on inlet and outlet pipes of rooftop open-air high-level fire water tanks should have protective measures to prevent them from being arbitrarily closed. 3. When setting up a high-level tank room, the environmental temperature or water temperature inside the room should not fall below 5 degrees Celsius. 4. The minimum effective water level of the high-level fire water tank should prevent air intake through the outlet pipe. 5. High-level fire water tanks should be equipped with ventilation pipes. Their ventilation pipes, breather pipes, and overflow pipes, etc., should adopt technical measures to prevent pests such as insects and rodents from entering the fire water tank. 6. The clear distance between the outer wall of the high-level fire water tank and the structural wall of the building or other pool walls should meet construction or assembly needs. For sides without pipes, the clear distance should not be less than 0.7 meters. For sides with installed pipes, the clear distance should not be less than 1.0 meters, and the width of the passageway between the outer wall of the pipe and the structural wall of the building should not be less than 0.6 meters. For tank tops with manholes, the clearance between the top surface and the bottom of the building structure above it should not be less than 0.8 meters. 7. The diameter of the inlet pipe should meet the requirement of filling the fire water tank within 8 hours, but the diameter should not be less than DN32. It is advisable to install a level valve or a float valve on the inlet pipe. 8. The inlet pipe should connect above the overflow water level. The lowest point of the inlet pipe opening should be higher than the overflow edge by an amount equal to the diameter of the inlet pipe, but it should not be less than 100 millimeters and not more than 150 millimeters. 9. When the inlet pipe is submerged outflow, measures to prevent backflow should be installed on the inlet pipe, or siphon break holes and vacuum breakers should be set up on the pipeline. The diameter of the siphon break hole should not be less than 1/5 of the pipe diameter and should not be less than 25 millimeters. However, when refilling with a domestic water supply system, the inlet pipe should not have submerged outflow. 10. The diameter of the overflow pipe should not be less than twice the diameter of the inlet pipe, and should not be less than DN100. The bell mouth diameter of the overflow pipe should not be less than 1.5 to 2.5 times the diameter of the overflow pipe. 11. The diameter of the outlet pipe of the high-level fire water tank should meet the discharge requirements of the fire water supply design flow rate, and should not be less than DN100. 12. The outlet pipe of the high-level fire water tank should be located below the minimum water level of the high-level fire water tank, and a check valve preventing fire water from entering the high-level fire water tank should be installed. 13. The inlet and outlet pipes of the high-level fire water tank should be equipped with valves that have indicators for opening and closing. Today we learned about the specific requirements for the installation of fire water supply equipment, including the installation requirements for fire water pools and high-level fire water tanks. Each installation method has its unique function, but the ultimate goal is to ensure the normal operation of the system and its effectiveness during a fire. I hope you can apply this knowledge in practice and become professionals capable of ensuring public safety.